ServiceNow X Factor. Hello everyone, welcome to Zero to Hero master video of ServiceNow Discovery. In this video, we are going to cover all the topics related to discovery and CMDB in ServiceNow. So stay tuned till the end to cover all the topics like identification and reconciliation engine, mid-server installation validation. We will be doing a lot of practicals here and everything will be demonstrated using the use cases to let you visualize the entire process of how we run discovery in ServiceNow. Interview related important questions are also discussed throughout the videos. This will help you prepare for your interview and answer like a pro. I'm sure this will give you an insight about ServiceNow Discovery in a way you have not seen before. So stay tuned till the end to cover a variety of topics to run discovery schedule, quick discovery, to learn about troubleshooting areas of discovery, to see what configuration console is, how we can use it in discovery, how it will be benefiting us. We will learn about credentials, credentialless discovery, and about discovery affinity by creating credentials and using it in the discovery schedule. And we will see how it is going to be helpful in the ServiceNow discovery. We will know how to track multi-source data and how to customize the port number, process classification, process handler, horizontal and application discovery patterns, use case. All this and much more is going to be covered practically in this particular video, so stay tuned till the end. Let's get started. In this video we will learn about identification and reconciliation engine IRE. As we know, in CI class manager hierarchy, here the classes are either modified or created, and you can set identification and reconciliation rules for that particular class. So let's learn more about IRE in this video. Identification and reconciliation rule provide a common centralized method for identifying and reconciling the data from different data sources. Which means if we are using ServiceNow Discovery or other discovery like SCCM to populate or update CI in the CMDB, use the same reconciliation and identification rule to see if the record is already present in the database or needs to be created as a new record. This reduces the chances of creating a duplicate record. There are three types of quality checks. The identification rules prevents any duplicate record to be created in the CMDB, reconcile the CI attributes, and reclassify the CI if needed. Reconciliation rules only allows authorized data to insert or update record in the CMDB. Last, relationship rules verifies that all the relationships that are required, they exist. Meaning that if there is any dependent CI that need to exist before creating the new record. So this is all about identification and reconciliation engine. The CMDB identification process relies on identification rules, and these are known as CI identifiers to uniquely identify the configuration items. An identification rule applies to a CI class and consists of a single identifier or more than one identifier entries, each with a different priority. Let's navigate to CCI identifier, type identifier in the application navigator. Under configuration, click on CI identifiers, and you can see the list of identifiers here. Let's go to, suppose, hardware. Here is the hardware rule. We will dig in and see what are the identifiers for the hardware class. So here we can see there are a lot of identifier entries in this tab, and each has different priorities, as you can see here. Correlation ID, priority 75, product instance ID, priority 90, serial number type, priority 100, name, priority 300. In this way, each identifier entry identifies a unique attribute set with a specified priority. And this is how this process can be viewed in the discovery schedule status record. Let's go to discovery schedules. So if you have any discovery scheduled here in the status, you can see for example, I have a screenshot of how it will look because we do not have anything here running currently. So this is how it will look. You can click on the devices and you can see that classification is done as Windows classified. The action is completed, status is updated CI, and this is how this process can be viewed in the discovery schedule status record. We can also navigate to CMDB identifier through CI class manager. We have seen this in other videos related to identification and reconciliation rule. Go to hierarchy, go to Windows, and here under the identification rule, you can see the priority related to the attributes and different identifiers. During the discovery process, a device will be classified and a CMDB record will either be created or updated using the identification rule. And this process can be viewed in the discovery schedule status record. This is all for this video, and if you like our videos, please subscribe to our channel, hit the like button, share the video, share the knowledge. We will see you in next video. Hello everyone. Today in this video, we are going to navigate through the ServiceNow Discovery application and CMDB. We will see various modules and features of ServiceNow Discovery. Let's start with the mid server. Let's type mid server in the application navigator, and here you see under discovery mid server table. From the table we can see the status is up or down, mid server is validated or not, and what is the IP address or host name. All mid servers connected to the instance display in this list. ServiceNow Discovery requires a mid server to be installed in a customer environment in order to discover accessible targets and to populate the CMDB. Next, let us navigate to the home page of the Discovery. Let's type Discovery in the application navigator. And here you can see the home page. The Discovery homepage provides a summary of discoveries that were triggered from configuration item schedules during the last 30 days, including errors that might have occurred. Next, let us navigate to the dashboard. We will click on dashboard under Discovery application. The Discovery dashboard is a central place for Discovery users to monitor ongoing discovery operations. The dashboard contains reports that query database for newly discovered devices and applications, total discovered devices and applications, and unfreshed devices and applications. Now let us navigate to Credentials module. So under Discovery, we'll click on Credentials. So here there are various types of credentials that can be found on the ServiceNow instance that allows ServiceNow Discovery to collect various types of target data. Common credential types are Windows, SSH, AWS, and SNMP. Next, let us navigate to Discovery Schedules under Discovery. A discovery schedule determines the frequency discovery executes and what target devices and or subnets are to be discovered. Also, from this page, a quick discovery can be executed, which allows an administrator to run a discovery on a single IP address without having to create a schedule. Next, let us navigate to the other module, which is behavior. Under discovery definition, you see behaviors. Discovery behaviors determine the probes that Shazzam launches and from which mid servers these probes are launched. Behaviors allow an administrator to target specific type of devices within a discovery schedule, such as Windows or Unix only type devices. Suppose we create a behavior named able, save it. Under discovery functionality, click new, and under functionality definition, you have the option to select target specific type of devices within a discovery schedule, which can be SNMP only, Windows only, Unix only, etc. For the time being, we do not want any behavior. We are just navigating through the modules. So let's delete this. Next, let's navigate to discovery patterns. Service mapping and discovery use patterns in their discovery process. The base system contains a wide range of patterns that cover most industry standard network devices and applications. On top of hosts and applications supported by default, you can discover additional hosts and applications by deploying the patterns available from the ServiceNow store. In addition, you can extend these patterns or create new ones from here. Next, now let us navigate to CMDB modules. Let's start with CMDB view. The CMDB dashboard displays aggregated CMDB health reports. For all major metrics and submetrics, the data is displayed in a tile format. Each tile being a widget, you can customize to display the information in a way that is useful for you. You can see in the relationship tab, we can see how many duplicate relationships, how many orphan relationships, and how many stale relationships are there. In the CMDB health chart, we can see the completeness, compliance, and correctness. CMDB health dashboard. This is a very useful place to visit and look for the matrix that you want to see. Last but not the least, let's look for CI class manager. We'll click on hierarchy. Let's search for something like Windows. Let's go into Windows Server. Here you will get basic info, attributes, identification rule, reconciliation rules, all these data in this CI class manager table. CI class manager can be used to centrally view, create, or edit basic class definitions and class settings for identification, reconciliation, CMDB, health, all of this. This is all for this video. We have covered navigation of ServiceNow discovery modules and features and CMDB modules. If you like this video, please subscribe to our channel, hit on like, and we will see you on the next video. Hello everyone. In this video, we will learn about CMDB Query Builder. Let's type CMDB Query under Application Navigator. Under Configuration, you can see CMDB Query Builder. Click on that. Let's click on Create New. You can see that we can create query in two forms, CMDB query or service mapping query. For your requirement, select the query you want to create. Here, you can create the complex queries without using the code. So this is a canvas where we can drag and drop and create queries. You can add relationships and or operator and form the query for which you are using the query builder. You can add the columns that you want in your table to show by selecting the application or by selecting one of these and adding the columns from here. So in this way, we can say that CMDB Query Builder feature provides a simple and intuitive way to query the CMDB for the CIs and relationship across the CMDB tables, including service maps. The user interface is a drag drop and enables the creation and execution of the complex query without the code, as we have discussed. Queries can be saved. Okay. Suppose we have a relationship here. And if we save it, you can see that we can save the queries, we can also schedule our query, and we can export the query in multiple file formats. This is all about this video. If you like this video, subscribe to our channel, hit on the like button, share it with your friends, learn together. We will see you in the next video. Thank you. Hello everyone. This is an introduction video for Discovery Overview. Discovery is an application provided by ServiceNow. So if you type Discovery in the application navigator, you can see that this is an application provided by the ServiceNow, which is not free. This needs to be purchased for use. This application helps us to find, classify, and identify the hardware devices, networks, routers, applications. And in order to identify, classify, get access to the internal network of the organization, mid server needs to be installed within the network of the organization. So having mid server in the customer environment will help mid server to communicate within the network of the customer with different hardwares and softwares that we want to discover. Mid server uses protocol HTTPS, which is on port 443, to communicate with the internal hardware and software of the environment of the customer. It is always advised to have more than one mid server for a couple of reasons, like in case of failover, the other mid server can complete the scheduled discovery task. And second, we need mid server closure to the location where the hardware and software that we want to discover is located. Also, if there are a lot of devices to be discovered, then multiple mid servers can have load balance between them. Discovery process can be stepped into 5-step process, and ECCQ plays an important role as a mediator between the mid server and the ServiceNow. In this ECCQ table, all the inbound and outbound instructions or probes, you can say, are stored, and from here mid server and ServiceNow gets to know what needs to be done. They get the instructions from the ECCQ. Mid server monitors the ECCQ for jobs to be worked. There are any outbound probes, mid server gets the job from the ECCQ and discovery initiates. For discovery to initiate, Shazzam probes are triggered to see which port is open, and accordingly in the scanning phase, that is the first phase of the discovery, depending upon which port is open, the particular device is classified. So suppose port number 135 is open, that means the particular device is going to be discovered as, that is classified as Windows. It is after the classification done based on which port was open after the Shazzam probe was triggered. Identification phase starts, and there the work of identification and reconciliation engine comes into play. Based on the CI identifiers, the device is identified. To know more about how identification and reconciliation engine works or what it is, we have a video on that. You can visit the video and you can learn about identification and reconciliation engine more in detail from that video. So this is all about this video. It is an overview of how the discovery works. We will see you in the next video. Until then, keep learning. Thank you for watching. If you like this video, subscribe to our channel, hit the like button, and share it with your friends who are learning ServiceNow. Welcome to our channel. In this channel, we will talk more about mid server. We will navigate through the modules and we will see what all we need for the installation and how to validate, what user role is required when we have to create user for the mid server, etc. etc. Let's proceed. Let's go in the application navigator, and type mid server. First, we need to create the user for mid server, and for that we will go to sysuser.list. For mid server, you need to create a user with the role of mid server. So for that, let's click on new from the user table and let's create a user for mid server. I will name it mid server user, mid, first name mid server user. Okay, let's save it. And now, as we talked about it, we will assign role of mid server. So we will type mid server and you can see mid server role. Let's bring it here in the roles list and save. So we have assigned mid server role to the mid server user. For real-time use, you should know that it is always recommended to create a mid server group, add the user to the group, and then assign the mid server role to the group. But here we will just proceed with this. And now let's navigate to mid server. If you see under the application navigator, you can see under mid server, there is installation instructions and downloads. If you click on downloads, you can see that we have two options: Windows operating system mid server downloads and Linux operating system mid server download option. If you click right here in the checkbox below, you have the option to download mid server as a zip file for Linux or Windows operating system, whatever is required. It is always recommended to download mid server for the Windows operating system because in that case you will be able to discover both Windows and Linux devices. But if you download Linux for mid server for Linux operating system, in that case it restricts discovery of any Windows devices. So it is always recommended uh, if you have both the types of devices in your organization, you should go with downloading mid server for the Windows operating system so that you can discover Windows and Linux both type of devices. For this video, I already have a mid server that we will work with to see how mid server is validated. So when we click on mid server under discovery, you can see all your mid servers in this table. Select the mid server and go to actions button, click on validate, and this will start validating your mid server. After some time, we can just refresh and see. So the status is already showing up. We just need to validate. You should know that using the same process, you can validate mid servers which are under maintenance or which has been compromised from doing any task on ECC queue. So now we will refresh and see if it is validated, and yes, you can see your mid server that has been installed, Windows mid server, is validated. Bingo. We will navigate to mid server dashboard. So you can see under mid server dashboard, you will click and here we have mid server dashboard here. You can monitor the mid server ongoing activities here in the dashboard. It displays information like mid-server status, mid-server issues, and in the performance tab, average percentage of CPU used, average percentage of maximum memory used, and here you can come and review how is your mid-server performing. So this is all about this video. We have learned about how to validate mid-server, where to go for installation. We have learned about what is mid-server installation under Windows operating system and what is mid-server installation under Linux operating system, what is the difference between the two. We have also navigated through the dashboard of the mid server. We have created user and seen what role is required to create a mid server user. I hope you like this video, and we will keep coming up with some more informative videos on different other topics for ServiceNow. Welcome to our channel. In this video, we will talk about discovery schedules, how to schedule a discovery. So let's navigate to discovery schedule from application navigator. Under discovery, click on discovery schedules. As I have also talked about this when we were navigating through the discovery modules, that there are two ways to run the discovery. One is quick discovery and another is scheduling the discovery. So if you click on quick discovery, all you have to do is select your mid server, whichever mid server you have or you have to work with, and select the target IP, and you can run the quick discovery. And the second option is you can create discovery schedule, and on that particular time the discovery will run. So when we click on new, this is how it looks. You can schedule discovery from here. You can select your mid server, name it, stage 1 discovery, suppose, give your runtime, and accordingly you can schedule the discovery. You can also schedule the discovery manually from the CI. This you can kick off discovery manually from the CI record, or if you use discovery schedule, it will automatically run the discovery on the time that you have given. Important thing to note here is to set up a discovery schedule, you need to have a role of admin or discovery admin. Now let's dig into each and every option and see what we have. For example, what do you need to discover? You have to click on that by selecting the drop down list. So from the drop down list, you can see you have few options, like if you have to, or if you want to discover configuration item, network, cloud application, certificate, services. Configuration items is the most common one that we use. In that case, new record will be either created or the existing CI record will be updated depending upon which port is open and if the discovered CI is already existing in the CMDB data or not. So if you discover configuration items, the finally discovered item will either be updated or created in the CMDB. Let us now try and navigate other ways in which we can create a discovery schedule. Let's go to application, navigator, type discovery, discovery home. So from here in the bottom left, let me zoom it for you. You have this option Discovery Quick Start. From here, you can go to Create Schedule, Finish and Run, and your discovery schedule will be created. Next, from the discovery home page, you can select on suppose Create Schedule, and this is the form that we have just seen. So it has directly navigated us to a new form under the discovery schedule where we can create a new discovery schedule, configuration item for the time being. There are different mid-server selection method. We will definitely see what other methods are and how we can use that for our benefit in the other videos. For the time being, I'll just keep it specific mid-server and select the mid-server that we want for the discovery, and that's it. Save the form. In the related links, you can see Discover Now. So when you click on Discover Now, discovery will be scheduled. So discovery homepage gives you the summary of the discovery. So this page, the discovery home, will give you the summary of the discovery schedules that are triggered for the configuration items, the configuration item schedules. So this is all about this video, and we will see you in the next video. If you like this video, hit like button, subscribe to our channel, stay tuned with us for more such knowledge about ServiceNow, and let's keep learning together. Thank you. See you in the next video. Everyone, welcome to our channel. In this video, we are going to see how we run quick discovery. So once you have validated your mid server, it is always a good idea to go to the dashboard of the mid server and see the status of your mid server. Any other pending jobs, any processing jobs that mid server is doing will be seen from the dashboard here. Average CPU usage, average maximum memory usage, etc. etc. So now, since we have set up and validated our mid server, just to confirm one more thing that I've talked about, that we can validate mid server from our action tab. We can also validate mid server by opening the form and click on validate here. It is showing invalidate because we have already validated our mid server. I just wanted to let you know there are two ways to validate your mid server. Now, it is always a good idea after validating your mid server to run a quick discovery and see how it is working. So let's go to discovery schedule. We have talked about different ways in which we can schedule discovery, quick discovery. You can refer back to that video. So here I'm not talking about that. For quick discovery, remember I said that we need target IP and the mid server for which we are working. So in this example, we will let mid server discover itself and see. So how we can do that? Mid server. We have the IP address here. You can copy this IP address. So it is showing 198.51.224.36. So okay. So now we will use this IP address to run a quick discovery. Let's do that. So it was 198.51.224. 36, I think. 36. Select your mid server and run. So we are here in the discovery status table. Let's open the form and see. So this is the ECC queue. So we have talked about discovery status. Here we will see the different probes that are sent through the ECC queue. We can keep refreshing to see the progress of the process. In the discovery log, you can see any errors. If it is showing any error. In the devices tab, you can see if the device is classified, the class in which it is classified, if there are any issues. Here we can see it is being classified as Windows in the class Windows Server. Here we will also see if this particular device is updated or created. So that will also be updated here when the process will complete. So if you go to ECC queue, you can see the different probes and patterns that are sent, like Shazzam probes were sent during the scanning phase, and then classification was done, and now probes and horizontal discovery probe is sent. So this happens during the identification and reconciliation phase to collect more data, which will help to finally update or create a new CI in the CMDB. So we will keep refreshing until we see that the status is showing completed. The state is completed here, and let's go to devices. So you can see this particular CI has been updated. In the discovery log, just look at this horizontal discovery probe that has been sent during the exploration phase. This is the pattern probe which is sent during the identification and exploration phase. We will talk about it more when we will dig into the particular CMDB CI. Just in a moment now. Click here under the CMDB CI. To see which record is updated. You get all the information here, serial number, model number, and scroll down. You can see there are other informations also connected, and these informations, the extra informations that you see here, are collected by the pattern probes that was sent during the identification and reconciliation phase. So if you have not seen that video where I have talked about how identification and reconciliation engine works, why it is important, you will you can just refer back to that video and see that during this phase pattern probes are sent and other informations are collected. On the basis of that, it is decided by the system whether the CI needs to be created if it is not existing in the CMDB, or it needs to be updated. So this is all about this video. We have just run a quick discovery. Congratulations to you all. You have just seen how to run the quick discovery, and we will keep learning and growing together like this. If you like this video, please subscribe to our channel, hit the like button, and thank you. We will see you in the next video. Hello everyone. In this video, we will talk about troubleshooting areas and what in these particular areas during the discovery phases you need to check if there is any problem. So this is going to be a very short and theoretical video only, where we will talk in key points that what are the areas where you can face problems during the discovery phases. So in this chart, as you can see, there are 4 areas where you may face problems during the process of the discovery, and these are connectivity, permissions, probe sensors, process classifiers, configuration. So I've tried to cover mostly all the areas that might give you a trouble. So in the connectivity, so if there is any problem relating to connectivity, it could be like internet access problem, proxy problem, firewall issues. So maybe the internal organization environment firewall is set up in such a way that it is not allowing the mid server to get or gather the information that is required to update or create the CI in the CMDB. Connectivity to the target devices, so you need to check if the connection between the target devices is properly established, proper authentication has been given. Next is permissions. So again, here we talk about whether proper authentication is given, access privilege. Do you have the privilege to use the commands that you're using? So for discovery, you know that you require either the role of an admin or a discovery admin. Do you have those particular privilege to access or do carry on the discovery process? Mid-server credentials need to be established. So during the classification phase, as we have talked about, the credentials will be checked, and if there is any problem, then you will have to troubleshoot that area. You will have to check the authentication again, rewrite the user ID password, and see if the connection is well established now. PowerShell, we will learn more about PowerShell later. For the time being, you should know that this is also related to any troubleshooting area of permissions. Probe sensors, process classifiers. So here what kind of problem you can face is information not returned as expected, or information is returned but it is not displaying correctly, or any process classifier problem. So in this case, you will have to debug and see where exactly the problem is, why the information is not being returned as expected. The last one is configuration area. So you have to check your IP ranges, mid servers are properly validated, status is up, the connectivity is properly established between the target devices. Sometimes there could be a problem with the behaviors, credentials, which we will learn about in the upcoming videos. Cluster and capabilities, CI classification, identifiers. So these are the troubleshooting areas. I have tried to cover all the points that you will have to take into consideration if there is any failure during the discovery. So thank you for watching this video, and I hope this will help you in troubleshooting the areas where you are facing any problems when you are running the discovery process. Thank you so much. If you like this video, Subscribe to our channel, hit the like button, and we will see you in the next video. Hello everyone, in this video, we will talk about credential-less discovery. So we know we need credentials to run discovery to gather information that is required to create or update the CI in the CMDB. But the credential-based discovery produces richer data in a very time-consuming way. So definitely it gives you a richer data, but it is very time-consuming, and if there is any error or the credential is missing, then it delays the discovery process. It prevents service map from completing. So ultimately, the concept of credential-less discovery comes into play. Here, the credential-less discovery is an interim method for discovery. It allows partial CI information gathering via the Nmap protocol, which is installed in the mid-server host. So let's learn more about this. So credential-less discovery gathers the data, but this data gathering is limited only to Windows and Linux. It supports the creation and modification of host and application configuration items before the credentials are created. So let's see from where you can enable the credential-less discovery. Let's go to mid server. Open your mid server record, and here in the related links, let me zoom it for you. You can see enable credential-less discovery. And once you enable this will install Nmap protocol on the mid server host, which is required by the credential-less discovery process to gather the information. One thing to remember here is that Nmap protocol uses reverse DNS to ID the host. If no host name is configured, the IP address will be used. Serial number is not captured by the Nmap. So the name field is used to reconcile the CI record here. So once you run the credential-less discovery, in the discovery status record under the ECC queue, you can see that the horizontal discovery probe has launched credential-less discovery. There are two types of probes that are sent during the credential-less discovery. One is for devices, that is credential-less discovery network device. Another is for applications, that is credential-less discovery application. And this horizontal discovery probe is responsible to launch which pattern probe is required. In this case, it has launched credential-less discovery network devices, that is to gather the information about the device. So this is all about credential-less discoveries. I've tried to cover all the points that is important to know about the credential-less discovery. What are the different pattern launch for device and the application. You have to understand that this particular credential-less discovery is only to expedite the process of discovery when the discovery process is taking a lot of time to obtain the credential. So in the meantime, this interim process of credential-less discovery can be run, and Yes, so this is all about this video. We will see you in the next video. If you like this video, please subscribe to our channel, hit the like button. See you in the next video. Thank you. Hello everyone. In this video, we will talk about credentials and credential aliases. When creating a credential, we can choose from a list of credentials that is required to discover a particular device. For example, SSH for discovering Linux or Unix devices, WMI for discovering Windows devices, SNMP, which is used to discover network and print devices, AWS, that is used to discover network and print devices, etc. etc. Just in a while, I'll show you the whole list in this video. For SNMP, you have to remember, or we should remember, that this is the only credential that will be evaluated in the scanning port phase. So when the Shazzam probe is sent during the scanning phase of discovery, SNMP credentials will be evaluated. Other than that, all the other credentials are evaluated in the classification phase. Let's go to Application Navigator and type credentials. And here under credentials, you can see connection and credential aliases. So this is where we add new credential that we can use or that we want to use. So the credentials that we create here, we use it when we are scheduling discovery schedules. And how to create credentials, click on new. Suppose this is for Windows server, type credential. We will create the credentials here now. Now you can see the list or the type of credentials that I was talking about in the beginning of the video. This is the whole list of credentials for Windows, for Linux, SSH, for network devices and printer devices, SNMP, AWS. So suppose we select Windows credentials here. Windows server, username, you can give anything. Okay. And now save. So this is how you have created your credential. Now how you can use your created credentials when you are scheduling discovery. Let's go to discovery. We will also talk about why it is needed. Why are we doing this? Of course, we'll do that. We'll just see how we use it. So suppose this was one that we created, right? I want to use the credentials here. This is, let me zoom it for you. This is where in the form you see credential aliases. Okay. down. You can see the credential that you have created is your lock. So now let's get to the important question. Why do we need credential alias? So without a credential alias, discovery schedule can access all the credentials present in the list in your instance, which is sometimes not desirable, particularly with credentials with elevated privileges. Credential aliases provides more control over which credential your discovery schedule is allowed to use by restricting unnecessary exposure to the privileged credentials. So now we will test our credential and we will try to run the discovery. So to test your credentials, let's navigate to connections and credentials. This is the one that we created. Okay, let's go inside. You can see there is this test credential here in the bottom left. Click on that. Give the IP address for this is for Windows, so 135 mid server that you have. Okay, and we will test the credential. Credential is validated, you can see. And now we can use this credential for discovery schedule. How will you know that this credential was used in the discovery of a particular device? So this is again very important question, and the answer is discovery IP affinity. So once this credential is used to discover a particular device through a discovery schedule, you will see the details about that particular device here under the discovery IP affinity. So the next time when you are trying to discover the same device, the system will look into the IP affinity first, and if particular credentials was previously used to discover that device, that same credential will be used again to discover that device and update the information. If not, then it will go to the list of credentials that you have in the instance, and from there it will discover the device using those credentials. So this is all about this video and credentials, credential aliases, how to set up credential aliases in the discovery schedule, and how will you know that a particular credential is used to discover a particular device. That is, you will come and see the discovery IP affinity. So we have learned about discovery IP affinity as well. So this is all about this video. We will see you in the next video. If you like this video, please subscribe to our channel, hit the like button, and thank you for watching our video. Hello everyone, welcome to our channel. In this video, we will talk about behaviors, and then we will run a discovery with the credential alias and the behaviors to see how it works. So what is behavior in discovery? Behavior is used to control which protocol the Shazzam probe launches. And why is it important? So that we can control which port we are trying to discover. We will see how it is helpful, how we can do that in this video. So for example, if we know that we only have to discover Windows machine, we do not need protocols like SSH or SNMP to be launched. in the SISAM probe. Our work can be done only with the WMI protocol. So only launching WMI protocol in the SISAM through the SISAM probe will help us to discover the device, and this can make the process really faster, because the system does not have to go through sending each and every protocol and then checking which ports are open, and accordingly process the discovery further. So now let us navigate to behavior, and you can see that there are two behaviors, one under service mapping and one under discovery definition. These both are going to take us to the same table. So click on any one, and now we will set up a behavior. Suppose we only want, okay, we will click new, and suppose we only want to discover Windows devices. I will name this as Windows only. So this is the name of my behavior. Okay, save, and we are not done yet. We have to create the functionality. So let's create the functionality where we will specify our mid server, which mid server to be used, which phase we will be using it. The phase is going to be 1, because in the SISAM probe is the first phase. In the first phase, SISAM probe is launched to phase will be first. Functionality will be what you want to be which port you want to see if it is open or not. We are working for Windows devices, we will go for VMI only. If you know that you are going to search only for Linux or Unix devices, you can search and select SSH only. So you have a list of options here. For SNMP, you can go and you can select if you know that you have to discover network devices or printers. Unix only for SSH, as said. So this is how we select the functionality. Select your mid server, which will actually use this behavior. Log it and save it. So now we have created behavior. The name of the behavior is Windows only. Let's go and create a discovery schedule and see what happens. So discovery schedules. Let's create a new discovery schedule. Windows device only. Very specific name. And discover CI use behavior. So here, because we have to use behavior, we will select the method use behavior. Okay, and when you select use behavior, you can see that previously we had the option of selecting mid server, but now we have the option to select behavior. And if you remember that we just created behavior and we have already mentioned which mid server is going to be used when we are going to set this behavior for this particular discovery schedule. So we do not need mid server to be specified again for this particular discovery schedule. It is already inside this behavior. So all done. Let's save. So for scheduling discovery, this is the first time I'm going to schedule the discovery now. For scheduling the discovery, you have to give quick ranges. So I'm giving this IP range here. And now when you mention quick ranges, you can see that it is being displayed here in the related tabs of discovery IP ranges. Now let's run the discovery. So once we run the discovery, we have our discovery status. Click in the discovery status. In the ECC queue, you can see since we have used behavior where only window devices needs to be discovered, the only SISAM, the only protocol that is launched during this SISAM probe is WMI. This is what we had set up using that behavior. So this is where the difference is. I'll show you once more using the same thing. If I do not use this behavior, then how many of the protocols are normally sent during the SISAM probe, so that you can just refer and you can just see the difference. So here we see that only WMI protocol has been sent. So this is how we restrict or we control that which protocol will be sent by the SISAM probe during the scanning phase. And we will keep refreshing it until it is completed. Once it is completed, you can see what was the problem, or was it discovered, discovery completed, any update or not update. Now let's do one more thing. This time we will create another discovery schedule. Okay, this one was the earlier one with behavior. Let's make a change here. It is also Windows devices. Fine. So this is another discovery schedule where we are using specific mid server. We will only mention the quick ranges that I have already mentioned here and click on discover. And you can see we have a discovery status here. This time in the ECC queue, you can see SISAM probe launched all these protocols: WMI, SNMP, SSH, HTTP, WNIS, DNS. All these protocols were sent in the SISAM with the SISAM probe. It was launched by SISAM probe during the scanning phase of the discovery when behavior is not set up. It is recommended to use behavior when you know that there is only particular kind of device that is going to be discovered using that particular discovery schedule. It will save time, and this is how we use discovery and why discovery is and this is how we use discovery, and you can see here it is updated. Finally the device is found and has been updated here. So this is all about why behavior is important, how we use behavior, how we create behavior. This is all about this video. We'll see you in the next video. If you like this video, please subscribe to our channel, hit the like button, and thank you for watching this video. Bye bye. Hello everyone, welcome to our channel. In this video, we are going to talk about how to discover router devices using behaviors, and we will see that if a particular device has more than one protocol running, how it will be classified using the classification priority, which is defined in the port group table. So there is a lot to learn, and also this video is an extension of our previous video where we talked about behaviors. I will provide the link of that video in the description. And for the time being, let's proceed with today's video. And if you have not seen that video, first watch that video and then come back to this video. So let's proceed with today's learning. Let's create behavior. For router discovery. Setup functionality. As we have already discussed, we will use this in the first phase, that is when the Shazzam probe is launched. Select Emmet server. Done. Updated. Now let's run discovery schedule. Click on new. Routers only. First, let me show you if we do not use the behavior, what happens. Make quick ranges. And discover. Now let's click on discovery status. Here you can see Shazzam probe launched all these protocols since we have not used the behavior specific for the router. What we have to see how this particular device is going to be classified, and we can see that this device, this particular range that we have selected, is classified as WMI. By default, this has been done. Why? We will talk about that when we will go to port probe table. Now I will run another discovery again. So actually, let's go to this routers only discovery schedule, and this time we will use behavior. And as in behavior we have already mentioned the mid server, so it will not ask for mid server again. We have chosen router only behavior that we have just created. Range is already specified. We'll click on discover now. So let us see what is the difference. In this case, you will notice only the SNMP protocol has been launched by the Shazzam probe, and the same device which was previously being classified as WMI will be now first checked if there is any network device to be discovered. Since it did not get any network device, only port that it was looking for, SNMP. It did not classify the device and as anything because it did not get any network device here. If it would have got, then you would have seen that it would have classified it as the SNMP, network and router. But the difference here, you can clearly see that it has not classified as WMI at all because it was not even looking for it. It did not even send the protocol of WMI, it was not looking for this, and it is the same IP address that we have used previously. Why this happens actually? So if you go to port probe table, in the port probe table, you can see classification priority. Let's bring it up. And you can see that WMI has priority 1. So because it has a preferential privilege priority given in classification, so if a particular device is running more than one protocol, it will use this priority and classify the device according to the priority that is first hit. So suppose the device is running protocols of WMI and SNMP. Because WMI has the priority 1, SNMP has the priority 3, it will automatically classify that device as WMI. If you change this priority from SNMP to 1 and WMI to 3, accordingly the device will first be classified as SNMP. It will not go to be classified as WMI. So this classification priority here makes the difference. So in this case, behaviors are again a very important concept. So uh, if you don't want to make any changes in the classification priority, you know that the device is running more than one protocol and you want that particular thing to be discovered, you can create a behavior for that. It will only send the particular protocol for which you want the device to be discovered and then accordingly classify the device. So this is all about this video, about the port probe table, about the classification priority, how it is working and how behavior can help you to override this classification priority. So if you like this video, subscribe to our channel, hit the like button, and we will see you in the next video. Thank you so much. Hello everyone, welcome to our channel. Today in this video, we will talk about how we manage multi-source data. So when you have data being discovered or devices being discovered by only one method like discovery, it is a pretty straightforward way to manage all the datas, and you know that they are coming from one source, so this is what it is. But if the data is coming from different sources, from multiple sources like from ServiceNow Discovery, SCCM, etc., then how we can manage that, how we can track from which source which data is being taken. So let's learn about this in this video today. In case of multi-source data, we have to determine that for which data, what source will be considered to be the trusted source. And for example, like ServiceNow Discovery can be a trusted source for CI class, manager, manufacturer details, like manufacturer attributes. whereas SCCM can be a trusted source for a specific field like RAM, CPU, and software utilization field. So let's see how we can enable this system property, and also uh, it is important to note that for this function or this property you need item discovery license to be installed, and we have to go to properties table system dot properties dot list. Okay, it's driving system. Okay, here we are. So in system properties table, you have to search for glide identification, glide dot identification underscore engine dot multisource dot enable. So let's see. Okay, this one, glide identification underscore engine dot multisource underscore enabled. So this is a true false field. You need to set the value to true. Once you set up this system property to true, you will be able to track the specific fields. They will be able to track actually the data sources from which the specific fields have been updated in the CMDB, and from there you can see if it is coming from the trusted source or not. So after enabling these properties, there is a table that we will talk about, and the table that is created stores the attributes of the CI from each data source. So now let's look at the table that we are talking about, that is created after we have enabled the system property of glide.identification underscore engine dot multisource underscore enabled to true. So this table is CMDB or multi-source data list, or you can say CMDB 360 degree. 360 data table. So since we have not yet uploaded data from different sources, so we are not seeing it over here, but otherwise it will show the 3MDB 360 data table here. Enables capturing this from CMDB classes. So once you upload the data from more than one sources, now you will get all the details about the specific field from which source it is being updated in the CMDB 360 data table. CMDB 360 data table. Okay, so see from all other places from where we can actually access CMDB 360 data. So we can also access CMDB 360 data from CI class manager. Click on hierarchy. click on suppose Windows, reconciliation rules, and from here you can see there is preview data. So you can use the preview data to also view the 360 degree and the 360 data, CMDB 360 data. Sorry, I'm again and again saying 360 degree, it's CMDB 360 data. The other place from where we can see it is from the CI table itself. So CMDB underscore CI dot list, and from here also you will see that you can see CMDB 360 data from the related tab list. So there are a lot of related tabs here. You can just add related list here. You will get the option CMDB 360. Like and see. And now here you can see okay, we will just reload the form. CMDB 360 data in the related lists. So this is how we can actually manage the multi-source data and see which field is being updated from which source, and see if that is a trusted source for that particular specific field. So this is all for this video, and how to manage and how to activate the multi-source data engine. Thank you for watching this video. If you like this video, subscribe to our channel, hit the like button, and we will see you in the next video. Thank you. Hello everyone, welcome to our channel. In this video, we will see how custom port can be created, or from where we can see which port number is being used to discover which type of devices, that is, which protocol is using which port numbers. So let's go to port probes table. Okay, from here, suppose SSH, you can see in this form, you can see there is a field called triggered by services, and the name here is SSH, which is a little confusing actually. This could be any other name also, but if you go to this particular record, you will be able to see which port is this particular protocol will use, to see that if this port is open, and accordingly classification will be done of that particular device during the discovery process. So let's open this record. We have already seen that this particular IP service is using the port number 22. We can customize this port number, so it is not always that your customer will be using the standard port number 22 to find the Unix or Linux devices. They might be using some custom ports, and how they can customize or how you can customize the port. You can just write, suppose 755. I don't want to mess with the original record, so I'll just insert and stay. So we will have two of this port. So let me also name it SSH2 actually, and then update. So let's go to IP services table where we have actually made this change in the port number, and search for SSH. So you can see there are two SSH. The first one will look for port number 22. The second one will look for port number 8755. And how you can include or make sure that your custom port is also being checked during the discovery to see if this port is open, and accordingly classify your device as Unix or Linux. For that, we will again go to ports table, go to SSH, and just under the triggered by services, add the custom port that you have just created and update. So now let's establish a credential first, and then we will schedule a discovery for Linux this time. Okay, so we need new credential for SSH. Yes, okay. So Linux only. Password save. Let's check for the credential. And you can see credentials are validated. So now let us schedule discovery schedule. Linux only. As you remember, we can use behavior only for SSH, only for Linux, by selecting behavior here. For this, you will have to create a behavior, and then you can come and select that. For the time being, I'm not doing that. Remember, we have also done credential aliases, which credentials need to be used. You can select that. Let's also talk about Shazzam batch size now. So by default, this particular discovery schedule will look for 1,000 devices at a time. in one batch size of the Shazzam, and then it will classify the devices. We can reduce this to suppose 300. We can change the Shazzam batch size. Now let us give range for discovery. For discover now. Let's go to the discovery status. You can see that it has been classified as Unix. So we have the Shazzam probe that has been sent. Let's look for which Shazzam probe has been sent and what all ports it was looking for. So here in the payload, you can see for which all ports it was looking for. Let's search for our port 8755. See, it was looking for this one as well. So this is how you make sure your custom port is also being searched for if it is open, and accordingly classify your device. So this is all about this video where we have learned how we can customize the port and make sure that it is being used. So to customize the port, we go to IP services table and create our own new triggered by services record and give the custom port that we want to give and select that particular triggered by service in the port probe table in the record. Suppose in SSH you wanted to do that. In SSH you wanted to suppose do that. You can go to the port probe and select your customized port. Under the triggered by services field. So this is all about this video, and we will see you in the next video with some more informations and more learning. If you like this video, subscribe to our channel, hit the like button, and thank you for watching. Everyone, welcome to our channel, and today this video we are going to just go over a quick tip in discovery. So there is something called discovery configuration console. I just want to show you by navigating there how does it look and what do we actually do there. So under discovery definition, here you see configuration console. Let's dig into it, and here you see you have a lot of options. So in discovery, if your organization decides that certain ports does not need to be scanned, suppose you do not have a Unix or Linux server and computers, so you do not want these ports to be scanned at all, and your device need not to be discovered as Unix or Linux. If you have such requirement for your organization, in that case this particular module is helpful. So in that case you will just go under discovery definition in the configuration console, and you can deselect these Unix servers and computers, or whichever is the requirement in your case, and that particular port will not be scanned in the scanning phase, and it will not be discovered as that particular device in the CMDB. So this is how you can regulate what you want to be discovered and which data you want to be entered into the CMDB. So this was just a quick tip of discovery. We will see you in the next video. Thank you for watching. Everyone, in this video, we will run a quick discovery and we will talk about Shazzam batch size also. So let's go to discovery schedule. Let's run Windows only schedule. Here we will be using behavior. If you have not seen my previous video on what is behavior, how it is used, we will put a link in the description and you can visit that video, and it will be really helpful because it is very informative video about how behavior can be helpful to actually narrow down the port scanning, and discovery will be faster because we have already specified which port need to be scanned through behavior. Now let's talk about Shazzam batch size. This is what we are here for today. So Shazzam batch size is during the port scan phase. You remember that Shazzam probes are sent to see which ports are open and accordingly classify the device. By default it is 1000 here. We can reduce the size or we can make the size the way we can actually reduce it and increase it the way we want it. What will happen unless this particular number of this particular number of devices has been scanned for the ports to see which port are open or not, the classification phase will not begin. If you will reduce this batch size, what happens is the system will not wait for the whole scanning to be completed. In between, it will start classifying the devices for which the ports has identified that which port is open. So this is about the Shazzam batch size. So Shazzam batch size decides that after how many device scanning has been finished, and the classification will start without the system waiting for the whole scanning phase to be completed. So let's keep it with 1000 right now. So we already have IP range here. Let's give another IP range and run the discovery. Here, after the discovery status is stated to be completed, we will go back to the dashboard of discovery to see how the dashboard looks after devices has been discovered, updated. So here you can see that the status is discovery status state is completed now, and It is classified as Windows. Let's go to ECCQ. You will see that during the Shazzam probe launch time, the only ports that were looked for was WMI, WINRM, and WINRM underscore SSL. Only these ports have been scanned. Why? Because we have used behavior. As you remember, we have used behavior in this. Let me show you again. And before going there, so our device is classified. We'll go to dashboard to see how it looks. So let's go to discovery schedule. So this is what our schedule was. Discovered Windows only schedule. The behavior was used Windows only behavior. And in this particular record, let's open the record. You see that the functionality that is used is Windows only. So it will look for WMI and WMIRM underscore SSL ports only. So now, since the device has been discovered, we have seen the status now. Let's go and see in the discovery dashboard. Discovery dashboard. So after you complete the discovery schedule, you should definitely come and see in the dashboard. This is how your newly discovered devices are being shown. Your total discovered devices are shown. This is what we have discovered and updated right now. The Windows one. Newly discovered applications, total discovered applications, any unused credentials. You can come to this dashboard module and see what informations are available here, how it can be useful for you every time you run a discovery schedule. So this is how I wanted to show you that using behavior when we run quick discovery, how we can go and see in the dashboard if our discovered devices are being shown here, and also how we make sure, looking at the Shazzam probes, that which ports have been sent. So this was our status that we were working on. So in the ECCQ, you can go and see when the Shazzam probe is launched, which are the ports that has been scanned for. So from here you will know that the behavior that you have created is working, and it is only looking for Windows devices. So this is all about this video. Thank you for watching. We will see you in the next video. Hello everyone. In this video, we will talk about process handlers. We have already talked about CI identifiers. If you have not seen that video, I will just put the link in the description of that particular video. It is very informative video of why CI identifiers are important and how to navigate from different sources to look into the CI identifiers and modify if necessary. Process handlers. The work of process handler is very similar to that of CI identifiers. Always, this is optional. The process handlers, we only need them to be used if the parameters have inconsistent values that can cause the duplicate applications because the main aim of process handler and CI identification is same, and that is to prevent duplicate data, to prevent the system to create duplicate data in the CMDB or in the applications. So if you have the parameters that are inconsistent, in that case, we can use process handlers so that we can prevent any duplication of the record. This is an optional configuration. Always CI identification is preferred first. But we should know about this, and so we are here in this video. Let's navigate to process handlers. Under discovery definition, click on process handlers. This is our process handler, mid server handler. Let me zoom it for you. So here you can see the condition that is given is the parameter if it contains com.service_now.mid. The script here, it takes the current command and adds to the parameter field of process when condition given is met. This particular process handler will perform the logic defined in the script and then decide if that particular record is already there and it only needs to be updated and not created again. Example, when a mid server application is running on a Windows server, a unique process ID application is given to the mid server, and if the mid server is restarted sometime, it will be given another unique process ID. So to make sure that the system does not consider this to be a new application or discover it to be a new application, process handler is used. So that it does not look like this is a second installation of the mid server, process ID looks to compare the unique value of the discovered application in the CMDB, such as installation path, and compares it to the process that is running. If the values are same, then it is considered to be the same application. So in this way, we use process handler for inconsistent values and make sure that we can prevent the duplication of application. So this is how process handler is useful, even though CI identification or CI identifiers are the recommended, or you can say the preferred options. Thank you so much. This is all for this video. I hope I was being able to clear the concept of process handler. This is a little off the other topics, less talked about topic, but I think if it is there, we should just have a little bit of base knowledge about what it is, how is it different, why it is important, and if it can be useful to us in any way in the near future. So I hope I could add some value through this video. See you in the next video. Thank you so much. Hello everyone. In this video, we are going to talk about discovery classification process. Discovery classification can be broken down into three types: device classification, process classification, IP classification. Device classification is the actual classification that me and you know that happens in the classification phase of the discovery. So This is the actual classification of the device, such as computer running on Windows or a computer running on Linux or Unix, maybe router, a switch, a load balancer, so on. Remember, computers and servers are classified based on the operating system that they are running on. Next is process classification. This is what this video will be talking about. Process classification is the classification of applications based on a process that they are running. Discovery classifies processes during the during the last phase of the discovery, that is, during the exploration phase, the application gets classified. Just like the device classification, process classification has its own classification criteria. So let's move into creating a process classification, and then we will talk about these criterias. Actually, the parameters. We have also seen these parameters and its importance when we talked about process handlers in my other video, which you can go to my channel and you can search and look for. So that is also a very informative and prerequisite of watching this video, that you should know about process handlers. So let's go and create a process classification. So let's type classification. So under CI classification, you will see processes. Click on processes. Here is your process classifications. Click on new. Name it iTunes table, application table. Relationship type. Now this is important. So we have to establish a relationship, so that in the dependency map view, when we will open this, it will show a relationship with the devices based on the relationship that we will add right now. So let's add runs on runs. Now here we have to give the conditions. Now this is the condition, the criteria that I was talking about. So based on this classification, the application is going to be classified. This needs to be the unique value. So our condition is name contains items and parameters does not contain helper. So this is the condition that I am adding. You may be given a set of conditions for your applications according to which your organization need that application to be classified. So accordingly, you will add that condition here. So here we make sure that we add unique values, and this will be to classify your application. So now let's save it. Done with everything here. Perfect. Now let's execute a new discovery. So let's go to discovery schedule, new discovery. So, application, server, IP, and discover now. Have you noticed there is a link called Show Discovery Timeline? If you click there, you can see the output Shazzam probe, input Shazzam probe being classified. So here you will get the whole list. Here you can see device is already classified. Now we are in identification phase. So after classification, classification is responsible to launch which pattern probe needs to be launched. So here, after classification, horizontal discovery probe is launched. State is completed. And we have one device here. So now, after the discovery is completed, let's see if ITOM is discovered. Let's go to applications. Configuration. Under configuration, you have applications. Let's click on that. Let's search for iTunes. Here it is. So this particular application has been discovered based on the process classification that we have classified. And we can see this runs on Windows Server, dependency view. And now here in the dependency view, you can see that our application has been discovered. And this is showing the runs on runs relationship. This relationship we have classified when we were creating a process classifier for the iTunes. So this is where the relationship is shown. And this runs on Windows Server. So I hope it was easy to follow that I clicked on this particular icon to go for dependency view map. Okay. So now let's navigate to servers. So under configuration, server, Windows. So if you remember, our application is running on Windows Server, so we are going to this. And let's try to locate IP that we created. Okay, we have to look for IP and then this particular IP address. So let's go and search again. We are just trying to see that in the Windows Server, this is showing in the application table. This relationship is showing just from both the records. We are cross verifying the same detail that under application, this is showing a relationship that it has a relationship with Windows Server. It runs on this, and the same we will do here under server Windows. We will just go and search for this, and we have got the record. And let's see if this shows the relationship with ITOM application, and here it is. So this was just a cross verification. Again, you can click on dependency view and it will do the same thing once again that we have seen. It is showing something related more to the Windows Server, of course, because we have come to the dependency view through this record. But yes, you can see that this particular application that we have just discovered, it runs on Windows Server. This is also showing here. So this is all about this video. I hope I was being able to give you more clarification, more detail on how process classification works and how you cross verify if your particular application is discovered and it is showing the relationship that it was supposed to show. So thank you so much, and we will see you in the next video. Hello everyone. In this video, we will talk about assets. So assets have many of the same attributes as CIs. Yet, assets focus on financial, contractual, and ownership details about the device. Therefore, asset management is about focusing on the cost and the ownership of the device throughout its life cycle. And this is where maintaining a CI record and managing an asset, that is asset management, is totally two different ballgame. These records are created when assets are procured or through the imports for the existing assets. Asset record can also be created through the discovery process when the CI records are populated, and it can be restricted not to populate as an asset every time the CI is created. We will see which option is used to do so. So let's dig into asset management, creation of asset, and let's learn something new today. So in this scenario, we will create a new asset and confirm that a CI record is created automatically after that. So let's see how we do that. Let's go to hardware asset. Let's navigate to hardware assets under asset portfolios. Create a new asset. And here now we will talk about model category, model. So before creating this asset, let's understand more about what are the important and mandatory fields and why it is. As you can see here, model category and model, these are the two mandatory fields when we are creating an asset. Model category decides if an asset will be an asset, CI, or both. This both field needs to be populated. Model category is used to associate CI classes with asset classes, meaning it will it will decide in which table the CI record will be populated. For example, if model category is computer and model is hardware, then record will be populated as a CI in the computer table because we have mentioned model category as computer. And this same record will populate as an asset in the hardware asset table because we have mentioned model to be hardware. The asset records are created when assets are procured or through the imports from existing assets. Asset record can be created through discovery process when the CI records are populated, and we will talk about that soon. So let's start with creating our asset. Model category computer, model INC, Alienware M17X. Okay. Asset tag, perfect. Serial number, this is a mandatory field. So you have to give serial number of your asset here. Let's save the record. And you can see that the name, we were not supposed to write in anything here. Okay, it was read-only field. And how does this display name got its name? It has derived its name by using the asset tag and the model number. So it has combined the asset tag and the model number and created a display name by itself. So it is a concatenation of asset and model field. Also, please note that configuration item, the name of the configuration item is the concatenation of the serial number and the model. So let's see if this CI is created. So let's go to the configuration base item computers, and remember it started with the serial number and the model number. So this is bingo. See, here it is. We created an asset and that asset created a CI. Where did it create the CI? As we talked about, since we have mentioned model category to be computer. So in the configuration item under the computer table, this particular record is created as a CI. So whatever will be the model category in that particular table, CI will be created for that particular asset. And this was the whole point of showing you how it works. So let's see if I make any change here, will it reflect in my asset record automatically or not? So suppose I assign this particular record to able tutor, our favorite. Okay, so let's save this record, and now we will cross verify if in the asset table this particular field is auto populated as able tutor or not. So fingers crossed. Let's go to hardware, assets. So let's, if you remember, the display name started with asset123. Okay, so this is our record, and this particular record is assigned to able tutor. Previously it was not showing this one, already verified that. Or you can, let's do it once more. Let's go to base computers, let's search for our record, let's make another change, let's remove able tutor from here and save this record. Let's go to hardware assets, search for a record, and assign to has been removed. So yes, you can cross verify like this. Whatever change will be made to the configuration item, that changes will automatically will be made to the asset record as well. Whatever change you make to the asset record, that particular change will be made to the, yeah, I'm having fun doing this. So we have just made a change here, and let's go and see in the computer table if it will reflect able tutor. Bingo, it did. So this is all about this video. We have just seen how the asset record and configuration item record are synchronized with each other. One last thing before we leave, I would like to discuss is enforced CI verification. So when I was starting this video, I talked about how we can restrict any CI to automatically form an asset record, because maybe we do not want every CI to have an asset record. Okay, so in that case, how we can do that? So let's go to our asset record. So this is our record. Here you remember this model category field, right? We will open this record. Here you can see there is a field called Enforce CI Verification. This checkbox, if we click on, it will override the automatic creation of asset. So every time a CI is created, asset record will not be created if we check this enforce CI verification checkbox. So administrator has the right to decide whether every time the CI is created, the asset record needs to be created or not created using discovery. And this enforce CI verification option is used then by the administrator, the admin. So let's wrap up this session today. Now we have learned about how to create asset, how it is different from CI, how it can be automatically synchronized, and how admin can override the creation of asset record every time the CI is created by enforcing CI verification. in the model category. And if admin does so, you have to remember that this will apply to the whole model category computer. So any asset record or any CI record that will be using this particular model category will be following this CI verification, and the process of creating automatic asset record will be overwritten for this whole model category if it is enforced by the administrator. So this is all about this video. We will see you in the next video. Hope you like it. Hope I added some value to your learning. Thank you. Welcome to our channel, everyone. In this video, we will learn about horizontal discovery patterns. So let's navigate to discovery status. I just want to show you what am I talking about. So let's go to suppose this first status, and you see this horizontal discovery probe. This pattern is being launched, and pattern is Windows OS server, because the classification of the device was in WMI. So it was a Windows device. Windows server classified as Windows. Windows server is the class. So based on the classification, we know that in the identification and exploration phase, horizontal discovery probe launches the pattern based on what was the classification of that particular device. So since it was a Windows server, so Windows OS server pattern is launched by the horizontal discovery probe. So today we will talk about what is this and how, if we need to extend uh, pattern, how we can do that. So let's start with that. So first thing first, what is pattern? Patterns are made up of series of operations that tells discovery which CIs to find on the network, which credentials to use, and which tables to populate in CMDB. Patterns like probes perform the same functions by identifying the device, exploring the device for attributes such as how much RAM, CPU, the operating system details, network configuration, and more. So patterns are executed during the classification phase and combines the identification and exploration phases during the discovery. This is an advantage over probes that patterns only create one record in the ECC queue, whereas probes create many in addition. Patterns are much faster at collecting device details than the probes. Next, types of patterns. There are two types of patterns: infrastructure pattern and application pattern. Infrastructure patterns are used to identify hardware or hosts, such as a server or a load balancer. And the second one is application patterns. So applications identify by a running process on the host, such as IIS or Apache or even Microsoft SQL patterns. So if you remember, uh, let me show you in the discovery status which application pattern was sent. So here you can see it's IIS. So for application, this has sent IIS application pattern to identify the running process on this host. Now, discovery patterns are divided into, or you can say broken up into two sections, the identification section and the extension section. So let's dig into the patterns and see what I'm talking about. Let's go to pattern, discovery patterns. So let's search for Windows OS. This is what the pattern we just saw, right? That Windows OS server pattern was sent by the horizontal discovery group. So the record is open, and here you can see that there are two sections. This is what I'm talking about, that patterns are broken into two sections, identification section and the extension section. The identification section is used to identify a CI through a series of steps and is a part of baseline pattern record. The extension section, whereas, is used to extend the identification section without actually changing the baseline pattern. That is your identification section. So if you have to make any changes in your pattern, extension section is the place which you will use and not the identification section. Remember, this is very important, that if you make any changes in the identification section, you own it. So if the version is updated or upgraded by the ServiceNow, this identification section will not get upgraded by the ServiceNow automatically. And this is the reason we will never make changes in the identification section of the pattern. Whatever extra you want to do, you want to add to your pattern, the new series of operations that you want to operate, needs to be added to the extension section only. Let's click on new and see what it is. So in the extension section, you can just give the name of the operation that you want to add. Suppose custom step. Order is 1, we can just let it be, and done. And this is how you add more series of operations to your pattern using the extension section. Now we will just dig into the pattern and see how it looks. So this was our pattern, right? Windows OS server. So let's click here. And this is how you can see the horizontal discovery log. This is the best place to actually troubleshoot where the problem is occurring, if any, during your identification and exploration phase. So here in discovery, you can see, just a minute. So why do we say pattern is a series of operation? You can see that these are the number of operations that are being performed already. What does this green means? Green means all these processes are successfully have successfully run. So this is how, if there is any red, you can just know that okay, this is where the problem is, and debug accordingly. One more important thing to remember here is that this is all the identification section operations that is listed here, because there was no operations that was mentioned in the extension section, as we have seen this record already. So if you add anything in the extension section, that particular series of operation will run after the identification section operation is successfully run. So first, identification section series of operations will run, and then the extension section series of operations will run in the pattern. This is how it works. Identification section steps within a pattern are used to gather the data from a device in a linear fashion, meaning the order of the steps is important on how it gathers and validates the data during the discovery. Each step will have an operation configured that dictates the purpose of that step. As an example, a step could be used to set a value pulled from the device into a field in the CI record, or a step could extract information of the device's registry and store it in a variable that can be used in later steps for validation of the device. There are many operations available in discovery patterns, making them very flexible in gathering and validating data. If any step is unsuccessful, the pattern may fail. So it's important to test each step to ensure it was configured properly. So now let's look at what are the pattern operations that are available. So we will again go back to the pattern that we were looking into, Windows OS server pattern. So let's go to discovery pattern, search for Windows OS server. This was the pattern that we were looking into. Okay, so in the identification section, this is the only section that has some series of operation. This was something that we did not even add any operations to. So we will just see what is there, and then we will come to our custom step and see what we want to do. So we just clicked on that discovery and look. So here, these are the series of steps in that is defined under the identification section. Every step is going to be performed one after the other. So the chronology here is very important, and you can see the operation that we are talking about is here, the pattern operations. So there are a lot of options in the pattern operation. Library references chosen here. As you can see, you have WMI query, you have SNMP query, unchanged user, parse file, parse variable. So pattern operations are grouped together based on their functionality in different categories, such as structure, query, parse table, operations, and others. These can also be selected under the operation drop-down menu. An operation must be defined during the creation of a pattern step. So this is the first step you can see. So this must be defined first in both application and infrastructure pattern. Both application and infrastructure pattern have temporary variables and values that can be written to the CMDB, provided the variable names are exactly named as the CMDB attribute names. So this is very important. that the variable name that will be used needs to be exactly same as the CMDB attribute names. Bonus tip in this video is few interview questions. How many types of sections are there in the pattern? So there are two types of section in the pattern, identification section and the extension section. What are the types of pattern? There are two types of pattern, infrastructure pattern and application pattern. Number 3 question is in which section of the pattern you actually make modifications to, if you have to make any modification in the pattern. Answer: we only make any modification or addition in the pattern in the extension section. We never mess with the identification section. It is the baseline operations. So this is all about the tip regarding the interview questions. If you need some more interview question related uh, tips during the videos, you can let us know and we will try to provide that. Thank you. And let's proceed with our video and talk about the different operations of the pattern. So now from here on in this video, we will talk about different types of operations that we have when we are creating patterns. So here under the operations drop down list, you see set parameter value. So set parameter value is the most common operations used in the discovery patterns. It allows the patterns to populate a variable with a constant value. It is an easy way to populate a variable and can be used multiple times throughout a pattern and gather information and validate against other variables. The syntax is important to understand when using this operation. So we will not mess with this particular section. Let's go to our custom step and select set parameter value. This is how it looks. The syntax is important to understand when using this operation, this set parameter value. For instance, the quotes represent a string value, as you can see here. It represents a string value entered by the pattern designer. Rather than having a query, the target device, these values can also concatenate values from other variables, such as combining the name of a device and the version together in a single string value. The name field here is using the $sign followed by a variable name. It will actually give you a whole list of possible variable names that can be used for your pattern. Maybe we'll just leave it like this for the time. Next, parse command. So parse command output is another commonly used operation. So this runs a command to extract information. When configuring this operation, you will need to define a parsing strategy to extract the information. The most common being delimited or regex. Delimited, regex, LDAP. Regex is your regular expression. So most commonly we use delimited and regex. So So if you try to make any changes here, you see it says that changes made in shared library. While saving the changes, you will have the choice either to save all changes, including the changed library steps, or save pattern changes only. So what is shared libraries? Shared libraries are a saved set of steps that can be used and reused between different patterns. Shared libraries help reduce the repeated creation of duplicated steps and allows for steps to be shared amongst the other patterns. Shared libraries are saved in the discovery patterns table and can only be modified from the pattern that they reference. Next, let's talk about merge table. The merge table operation is typically used as a final step within a pattern. Its purpose is to take content from two source tables and merge them into a single target. This operation can be used to merge tables based on certain criteria from any other existing variable in the pattern. There is also the option to remove all unmatched values or to keep them for later use as variables within the pattern, which is here. You can either keep them or remove them within the pattern. Next is transform table. The transform table operation is similar to merge table, yet works on one or two tables and does not merge matching variables. Instead, you can add one or more computed variables to an existing table. Then place the results into the target table. So third table will be created, or in the third table, the result will be shown. It's a way to unify information from different sources. The next operation that we will talk about is WMI query. WMI query operation is used to gather information for Windows operating systems depending on which namespace is selected. So depending upon which namespace you select, the information for the Windows operating system will be gathered. WMI data can be filtered by using a condition clause which will be reflected in the get full statement field here. The next is SNMP query. SNMP query operation is used to gather information from devices running the SNMP protocol, such as printers, network, core devices or power devices, servers. Basically, any device that has port 161 open and responds to this query operation. SNMP queries the device's management information base, also known as the MIB, by either individual attributes using scalar variable type or many attributes using variable type of table. MIBs are populated by the manufacturer of the device, so it's important to load the device's latest MIB information into the ServiceNow platform before running the discovery. So there are scalar and table, two types of variable type here. Remember, it is always the best practice to use dynamic values query from the target instead of hard-coded values, as these values on the device may change. That is, suppose we were talking about set parameter value and we were talking about this value. So always try to use dynamic value instead of hard-coded value, as these values on the device may change. Here you can see there is a debug mode. So if you have the IP address for which you need to run the debug, you can just write your IP address, connect. You have to have the valid credentials. Your mid server is in place, status is up, validated, active. Then when the discovery runs, and if this debug mode is connected already, then you will be able to see how your pattern is running step by step. And if your pattern has failed, you will be able to recognize in which step actually the pattern is failing. And you will be able to debug using this debug extension section. So this is all about this particular video, and thank you for watching, and we will see you in the next video. Hello everyone. In this video, we will talk about application discovery pattern. So in our last video, we have already seen infrastructure discovery pattern. So if you have not seen that video, you can go to my channel and you can search for horizontal discovery pattern. Let's go to discovery patterns under pattern designer. And let's search for Windows OS. So here you can see that Windows OS server is one of the pattern, and the pattern type is infrastructure. So infrastructure discovery pattern is basically used to discover devices such as computers, server, network devices, and so on. Let's click on new here in the discovery pattern table, and here you see there are three types of pattern type: application, infrastructure, and cloud. Cloud resource pattern type is used to discover these devices running on the cloud, such as Azure and AWS. In this video, we will talk about application pattern type. For application pattern type, you have to remember that this pattern runs for both horizontal discovery and top-down discovery, that is service mapping discovery. So this is a very important, you can say, interview question as well, that application pattern runs on both the types of discovery, horizontal discovery, and also on service mapping, that is top-down discovery. Let's name this as iTunes. Here you have to mention CI type. This CI type needs to be same as the CI class. For application, we will use application table with CMDB underscore CI underscore application. Now, very important for even interview question as well. Here you see there is a checkbox known as enforce process classification. So when you have to create an association between your pattern and your process classification that you have defined to discover applications, for that you will have to check this enforce process classification checkbox in your pattern record when you're creating your pattern. What we will do in the process classification, that we will see when we will go to process classification right now. So this video is, you can say, an extension of process classification video. So if you have not seen that video, you can go to my channel, you can refer to that video first. That is a prerequisite before you see this video. So there I have explained about what is process classification. We have created a process classification. We have run a discovery schedule. We have discovered application using that process classification. So definitely that is a very informative and very important prerequisite video before you see this video. So please refer to that video and then come back to this video again. So we have checked on enforce process classification here. Click on new in the identification section. Name it as iTunes identification section. Here you see we have to mention entry points. So to create connection between the patterns and the port, we need entry points. So for like internal connections, you can use TCP or Citrix. And if you don't know which entry points you have to use, you can just click on all. That's totally fine. So since I know that I have to use TCP endpoint and HTTP, sorry, so I'll use these ones. If you just don't know which entry points to use, it's totally fine to go with all. What is this listening port? So this is a process strategy. Actually, every entry point has a port number. So like HTTP is listed on port 80, HTTPS is listed on port 443. So this is that listening port. So here we do not have to do anything else. Just click on done. And this is it, your pattern is created. We have not added any steps to this pattern yet. First, we will create the association between this pattern and process classification. We will run the discovery schedule. We will see that this pattern is being launched by our discovery schedule during the discovery process, and then we will come and add some steps here to extract some information. This is the reason why we create pattern, right? We create pattern to extract additional information about the device that has been discovered during the discovery. So that we will do later in this video. First, we will just create the association between the process classification and the pattern. We will run the discovery and see if this if this particular pattern is being launched during the discovery process. So let's save it. Okay, another important interview question here. So I'll just take a little bit of time. You have seen that when I just showed you the pattern type, infrastructure pattern type, there were two sections, identification section and extension section. But in the application pattern type, there are three sections, identification section, extension section, and connection section. So very good point of difference to remember. So let's publish this pattern. Now let's go to classifications. Click on processes under CI classification. Click on processes. And here you have your process classifications. Please guys, if you have not seen my process classification video, refer to that video first. Click on this item. We have created this particular classification in that video. So definitely this video is an extension of that video. So to create association between this process classification and the pattern that we have just created, we will scroll down. In the related tab under trigger probes, click on edit. Type horizontal pattern. see, and here mention your pattern. So pattern is iTunes. All right. Okay, so this is how you associate your pattern with your process classification. And you remember when we were creating pattern, we have just checked enforce process classification checkbox there. So perfect. Update this record. Let's run the discovery schedule. Let's move to discovery schedule. We will run a quick discovery here to ensure that the pattern that we have created is being launched. So here you see I have already given the IP address, the range. So just click on discover now. So if you have any doubt related to discovery schedules, please check videos on my channel. I have already listed a lot of videos now related to only scheduling the discoveries. So I'm sure if you will just go there, all your doubts will be cleared of how to schedule a discovery. So in the status, we will keep refreshing until the state is being shown as active. Till then, let's talk about Shazzam Pro. So here you can see during the port scanning phase, the Shazzam probe is sending so many protocols. We can narrow down the number of protocols being sent by the Shazzam probe by using behaviors. So if you know that you have only a particular specific device to be discovered, you can use a particular behavior that will send only the protocol that is required to discover that device. So if you have not seen my videos on behaviors, please refer to the videos on my channel related to the topic behavior. I am talking about it here right now because I'm just waiting for my discovery status to be completed. So it is completed now, and you can see here that our pattern that we have just created, iTunes, is being launched. So after the Windows OS server was launched, after classification, so classification phase is responsible for sending the horizontal discovery probe, for sending to decide what pattern needs to be sent. So once it was classified as Windows server, it has sent Windows OS server. Once it has discovered application based on the process classification that we have created, it has again launched the pattern for classification, and this happens in the exploration phase. So here we can see that pattern iTunes is launched. This is what we wanted to check before we create any steps in our pattern. So now let's go back to our pattern and create some steps. Under pattern designer, navigate to discovery patterns. Search for iTunes. Here it is. So now we will create steps. Okay, why I'm creating steps in the identification section? When I said that identification need not to be touched, that is because this is a new pattern. I'm not messing with the existing patterns identification section. This is what we have created. There are no steps in this pattern. We are going to create those steps now. So before creating any step, we will first enable the debug mode, which is very important. As I've already said earlier in this video, that application pattern runs on both horizontal discovery and top-down discovery. So you will have to select the debug type for which kind of application pattern are you using this. For horizontal, you will have to mention the IP address and the process ID. So for process ID, first let us give the IP address. This is the IP address for which running discovery as well. This is the range that we entered in the discovery schedule. For process ID, okay. So for process ID, you will have to make sure that you use the current process ID. Where will you get the process ID? Our device was Windows Server. So we will go to Windows Server and we will search for this particular IP device. And in the related tab list, there is running processes. From there, we will get our process ID for iTunes.exe. So, lot of theory. Let's go and see how we do that. First, let us give the IP address. This is the IP address for which running discovery as well. This is the range that we entered in the discovery schedule. For process ID, okay. So for process ID, you will have to make sure that you use the current process ID. Where will you get the process ID? Our device was Windows Server. So we will go to Windows Server and we will search for this particular IP device. And in the related tab list, there is running processes. From there, we will get our process ID for iTunes.exe. So, lot of theory. Let's go and see how we do that. So, let's navigate to Windows under servers. So, our device was Windows Server. And we will search for the IP address. This is what we are working on. Okay, yes, this is our device that we have just updated during discovery. And here under the related tab list, you see running processes. Click on running processes. You can see PID, process ID is mentioned here. For what name we have to search process ID? iTunes.exe. So here is your iTunes.exe. You can see there is a comma, 2,444. We will not use comma when we are enabling the debug mode. We will just write 2,444. So sometimes this process ID gets changed. So it is very important when you are running the debug mode or when you are enabling the debug mode, you come here and for the current process ID. So let's go and add 2,444 to the process ID. And then connect. So your debug mode is on. Okay, so we will extract name, version, and vendor information through this pattern. So we will create steps to extract information of name, vendor, and version through this pattern. So first, let's name the first step as collect application name. WMI query. In the namespace, remember if you click on drop down, nothing will come. We have to click on get data. Now, if you click on drop down, you will get your options. So we will select root CIMV2. Table name, Win32 underscore product. And field. So remember, we need name, version, and vendor. So select name, select vendor. So please note when I selected nothing, okay. So this get full statement has nothing written over here. As soon as I'll click on the name of the fields, name, you can see name is added here, vendor, version. So you have all three here. So you do not have to worry about the code. It is getting written by itself. Okay, you just have to select the fields that you need to need from this pattern. So whatever data you need to extract using this pattern, you just select the field name. And now we will mention the target table, and our target table is going to be the application table. Why is this giving me details on its own? So our target table is application table. So as soon as I selected the application table, you see there is a plus sign here. How to get rid of that? You can just either click on the backspace or the tab button and it will go away. So now we have created our first step. Congratulations. Let's test our step. So when we are creating steps in pattern, it is very important and it is mandatory. It should be to test your steps one by one. So let's click on test. And in this way, you will know that you are being able to extract information using your pattern. And you see, test successfully completed. And these are all the informations that you are getting about your application. Perfect. So now we will add another step. Let's go to step number 2. So let's name this step as filter table and the operation as filter table. So about what operation I'm using, why I am using. So I've talked about the theory of the operation types in my horizontal discovery pattern video already. So this video is basically more of practical video. So I will not talk about the theory why I'm using what kind of operations. So you can refer back to that video. You can search for horizontal discovery pattern video in my channel and you will get all the theory related data on what are the operation types, which operation type is used for what. So here we will just concentrate on creating steps. CMDB CI application. Get rid of your plus sign. and the target label is also CMDB CI application. And conditions, so condition will be CMDB CI application brackets dot name contains items. So let's test our second process. The test is successfully run. Close it. Let's create another step. In this step, from now we will just set the application name, set vendors, set version. Okay. So for that we will use set parameter value, which is the one of the most common operation that is used. So set application name. Perfect. Set parameter value. Perfect. Why I'm using $sign again and again? So very important. I'm using $sign again and again because we want dynamic values and not hard-coded values. Since these values keep changing, we want our pattern to work even when the values change. So we will try to use the dynamic value. This is also something which is very important for interview questions as well. And I've also talked about it when I was talking about values and talking about the theory of operation type that we will use. We will try to always use dynamic value instead of hard-coded value. And this is what I meant. So I'm using $sign here because of that. So primary host name, CMDB application dot name, name plus sign. Actually, I just need name. So perfect. Let's test this step. So you see, you get the name and your value. So test run successfully. Next step, we will set vendor. So set name and vendor now. Set vendor name. Set parameter value. CMDB vendor plus application vendor. Get rid of the plus, either backspace or tab, and test. So here we should get the vendor name using this step. Perfect. And now last step, we will set version name. Set version name, operation, set parameter value, CMDB vendor, You will not get this the way I'm getting. If I would not have got something to select, I would have definitely written it. So since I have done it so many times now, so it is showing me the options like this. Okay, so it's not common that you get these. And see, selected vendor, I have to select version, not vendor, my bad, version. Yes, version. This one. And get rid of the addition. Let us test the final step, and we are getting the version here. So we're getting all the details that we need here. Now we will run the discovery schedule and see if we get these informations in our record of iTunes under the application table. So let us save this. And publish it. So what I mean to say is, let me show you in the application table. Okay, so in the application table, after discovery schedule was run, when we created the process classifications, in the process classification video, we saw that iTunes was discovered. Okay, so here there is no information about version and vendor. So through these steps in the pattern that we have just created, we want these informations to be shown here in this record, in the application table, in the iTunes record. So before that, since we have already created our pattern is already associated with process classification, we need to synchronize the updated pattern with our mid server. Let's go to mid server first. This UI action, pattern sync to mid. So here, when you click this, it will start syncing your updated pattern with the mid server so that mid server can use this during the discovery process. So this takes some time. Now let's go to discovery schedule, and we will run discovery for the IP range that we were working on, that is 198.51.12.119. Click on discover now. Click on the discovery status. Let's click on refresh until the state is being shown as completed. So classification is already done, and classification has sent the first probe, which has launched the pattern Windows OS server, because the device that was discovered was Windows Server. This is all we have seen. Application dependency mapping started. Our pattern iTunes is launched. and the state is being shown as completed. So this is all that we need to know about application pattern that we have covered in this video. I've tried to cover all small details and interview questions that are important related to this particular topic. I hope you found this video informative enough. So now let's go to application table and see that our iTunes record has been updated by the pattern that we have created or not. We have just run the discovery. Let's search for iTunes, and here you can see that vendor and version both are updated in the iTunes record. So this is all for this video. I hope I have added some value to your learning. We will see you in the next video. Thank you so much. Thank you for watching. Hello everyone. In this video, we will talk about IP Affinity. So if you remember, where do you find Discovery IP Affinity records? We find it under the credential table. So navigate to credential table under Discovery. We have created two credentials, Windows Server, Linux Server. Let's go to Windows Server. And here you can see Discovery IP Affinity. So if you have not seen my credentials video, you should definitely refer back to that video where we have created these credentials and then come back to this video, because this is an extension to that particular video. In that video, we just talked about the credentials and we did not talk about Discovery IP Affinity. So here in this video, we will talk about Discovery IP Affinity. What do you mean by Discovery Affinity? This shows that this particular credential was used to discover this particular device, which has IP address 198.51.12.119. So every time now when the discovery schedule will be run against this particular IP address, the system will use Windows credential, this particular credentials always. So this makes discovery faster, because when first time you are running discovery against a particular IP address, the system goes through each and every credentials to see which credential is valid for the discovery of that particular device. But once the discovery has already run against a particular device using a particular credential, in this case Windows Server credentials, then this Discovery Affinity table takes that record into consideration, and from the next time whenever you will run the discovery schedule, quick discovery against this particular device again, the system will first go to IP Affinity table, see if this device was already searched using a particular credential. If yes, it will use credential from IP Affinity table, Discovery IP Affinity table, and it will not go and look for all the credentials to discover that particular device. I hope I could add value to your learning through this video, and this is what I wanted to talk about which I said in my credentials video that after running the discovery schedules, I will come back to this topic and I will explain what I meant by discovery affinity table and how discovery IP affinity will be helpful to expedite the process of discovery. So thank you so much for watching. See you in the other video. If you are preparing for your interview or certifications, you can go to examhelpdesk.com. The link to the website will be given in the description below. This comprises of questions for different IT related topics like AWS, Cisco, CompTIA, Salesforce, ServiceNow, Microsoft. Give mock examinations for your interviews and certifications to see how well you are prepared for your interview or certification exams. You also have the option to download the complete list of Q&A. If you feel unprepared, you can click on the link and get your own complete set of list of questions and answers. This will definitely help you improve your interview preparation or certification exam preparation. Happy learning!